Good morning, everybody. I will wait for a few minutes to let everyone arrive, then we can start. Okay, let's start now. So, good morning in the name of the whole DIH team, and most particularly the DIH team at LIST. I'm very glad to welcome you on this webinar. Those Wednesday morning webinars have now become routine, and we are very glad to have you on board. I will give a first introduction of what we prepared for you today and of the different services and activities apart from the webinars that you can access within DIH. And then I will leave the floor to my colleague, Eric Roseren, who will give you this presentation about what computer vision can do for industrial application and illustrate it with a few of our previous experiments and projects at least. So next slide, please. Yes. So the DIH in Luxembourg is aimed at supporting manufacturing companies, industrial companies, through their digitalization path. To this, we are a whole set of partners: Lux Innovation, the House of Cybersecurity, the University of Luxembourg, and us, LIST, who are delivering you services and support for your digitalization. Our goal, at least, is to help you test some digital opportunities and see how you can use them to support your business challenges. For this, we have a lot of infrastructure. We have visualization wall that helps visualize large data sets and control them with a tangible table to support decision making into complex environments, in digital twins or coordinating activities in different locations, for instance. We also have a cognitive environmental lab to support collaborative decision making too. We have an immersive arena to test some scenarios and immerse people within large data sets as well. We have tested this for autonomous vehicles as well. We can organize many workshops. I will tell you about those workshops in a few minutes. I promise I will keep this as short as possible. And we have a car lab, a mixed reality lab. You may have attended the mixed reality workshop for industrial application. And we have a 6G lab to experiment with connectivity issues. All those infrastructure we put at your disposal to test and experiment. So if you want to, we organize regular visits, but if you want you want to visit them and us to show you what we have experimented with industrial partners based on those infrastructure, we will be very glad to welcome you at least. Next slide, please. Okay, so based on this infrastructure, we have developed at least a bunch of services aimed at supporting you progressively through your digitalization path. The first ones are the tech talks, just like this morning. They are totally free and open to everybody. Happen on Friday morning, and we give you just a little hint, a little overview of some industrial digital applications for industries. If you are interested in one of those, you can come from the hands-on test. These are hands-on workshops where you can experiment hands-on technology, some technologies based on real industrial use cases. And these are totally co-financed for industry during the project phase as well. That is until June 2026. And if you have identified one technology that will really help you with your business challenges, we can provide you, for your company, a tailored support to build the requirements for your tailored digital solution. So you can go to the next slide, please. I will just show you rapidly the DIH talks, like the one we have this morning. We have treated topics like data and AI, connectivity, no-code platforms. We have also visited our composite manufacturing lab. We have been talking to you about blockchain applications for industry, extended reality for training as well, and for maintenance and data storytelling. We are having one on computer vision this morning, and the coming ones will be user-centric design and tools in May. Then we can meet also, we will be at Nexus, and I guess you will too. Then on June the 20th, we'll have another webinar on IoT prototyping for industry to collect data and build dashboards. And we'll have one in October on the AI Act. So these are the webinars, the Friday morning webinars that you can attend, where you will get some insights about digital applications for industry. Then you can go to the next slide and register for a tech test. So these are hands-on workshop where you will really try, you will come to us, or we can come to your company if needed. And you will try some concrete tools and software for different applications. So on June the 19th, we'll have one on predictive maintenance. That was the last talk we had. In September, we'll have one on data acquisition and visualization. In October, we'll have a very exciting webinar, workshop as well on extended reality with Unity into our extended reality lab. November, we'll be testing some UX design tools for industry. December, data storytelling. January, blockchain workshop. And the workshop that will follow this tech talk we are having today will take place on February the 5th. So make sure to check on the DIH website and register for those workshops, which are totally co-financed during the project phase. So free for companies until June 2026. If you want to go further, to the next slide, then we can support you into building your digitalization roadmap. This happens through 2 working sessions. This is dedicated to your company. We explore your business challenges and suggest you some AI, data analytics, or any tech solution that can help you with those business challenges. So we define a use case, and during a second workshop, we work on your capacity. So what are the infrastructure, the skills, and the data that you have in-house and that we can use? After these 2 working sessions, you get the requirements for your own tailored digital solution to meet your business challenge. And as you know, at least we are a research center and we are independent and neutral. So we will provide you with different options, technological options with no vendor lock-in. And if you provide us with some data we can already experiment on, we can have a little workshop dedicated to you based on your data sets to experiment some options. So these are the services that the Test Before Invest services that we list are delivering and that are co-financed during the project. So let's get back to this morning's workshop. And I will now give the floor to my colleague Eric Roseren, with whom and with Prune Gauthier, so as the team at least, we prepared this workshop. And he will tell you about his experience and show you the different solutions that we developed and experiments that we developed at least. Thank you.
Okay, thank you, Laurence, for the introduction. So good morning, everyone. Welcome to this webinar on computer vision for industrial application, organized as part of the Test Before Invest initiative. So I'm Eric, I'm a data scientist here at LIST, and I will be your speaker for today. So together we will explore how computer vision is transforming industrial processes, helping companies improve efficiency, automate certain tasks, and enhance quality control. But before we start, a quick note, feel free to ask any question in the chat. We'll have also a short Q&A session at the end. And I'll take also some regular break in case questions piles up. So let's begin. So at its core, computer vision is an AI-driven technology that allows machines to interpret and act on visual data. It combines hardware equipment, so cameras, but also image processing algorithm, and deep learning models to identify, classify, and analyze objects in images or videos. So we are seeing an explosive kind of growth in computer vision adoption, mainly due to Industry 4.0, smart factories, and a surge in automation needs. So industries are slowly moving from manual, humans-dependent inspection to fully automated AI-powered system. We can kind of think of it like if a human inspector can check for defects in a product, a well-trained computer vision system can do the same, but at scale, so with more consistency and speed. So the agenda for today is we'll briefly talk about some potential application that are in the industrial context for using computer vision, some real-life examples that we encounter a bit every day and probably not aware of, and also the project we are working on at least where we actually leverage this technology. We kind of highlight the benefits and the key use cases. We'll also talk about a case study we had a few years ago with a Luxembourgish company. We'll mention also the different tools and technology, the tech stack we use, and briefly kind of talk about the challenges and the solution that we found. So yeah, kind of just a brief formal definition. So computer vision is a field of AI that enables systems to capture, process, and analyze images or videos to perform tasks like detection, measurements, or autonomous navigation. And these systems are powered with AI, and then they can automate tasks that are traditionally done by human inspectors. And all it needs is to combine some cameras, good lighting, and well trained algorithm. So if you imagine a manufacturing plant where you have products that are moving down a conveyor belt, traditionally a human inspector would manually check for scratches, misalignments, or missing components. But now with the computer vision system, this can be all automatized, and it can automatically detect defects and flag the issues for removal at a greater speed and consistency than a human can do. So if some of you have already used some form of computer vision in your operation, I'm quite curious, so feel free to share it in the chat. I'm also interested to see what is your technological background. So I've have a small poll as well that maybe we can launch. So I just have an idea. Okay, yeah. So I think just need to wait a few just to have the answers. But I can still check that a bit later. It's not a problem. Okay, great. Having the result now. All right, perfect. So okay, I will continue then. So what is really driving this computer vision boom? So lately, it's kind of a combination of several key factors that are driving this rapid adoption. So we are seeing more and more researchers focusing on really advancing the algorithm. So there are tremendous breakthroughs that have been done the past 5 years, and it's continue going. Also, cameras and sensors and GPUs are becoming cheaper and also more powerful. So that's also a key factor. There is more and more available data. With social networks, there's a lot of images and videos that are being collected and labeled. And there is also a strong incentive in the business side. So there is a business needs to kind of lower the cost because the labor cost is increasing, and there is a need for automation that provide that computer vision can provide with quite efficient gain. So there are some main, let's say, application of computer vision system. So, for example, in industry, there is in the quality control, we can easily detect any surface defects with the computer vision system, check the dimension, and make sure the assembly line is running smoothly. Regarding the process automation, some robots can be guided via cameras. There is also SLAM, which stands for simultaneous localization and mapping. Think of it as your smart vacuum system at home. If you have one, it can navigate in your home and localize itself while actually mapping the surroundings. So these are all systems that use computer vision. For safety monitoring, so detecting any hazards, and also regarding logistics for package sorting, and OCR, which stands for object character recognition. And we'll talk about OCR a bit later. This is the case study we did with a company a few years ago. I'm just checking with the poll. Okay, so I now have a better idea of the background of everyone. So now let's move on from industrial environment and just to see a bit everyday examples that you might already be familiar with. So in Belval, for example, there is the park and ride that actually automatically scan your license. So this is an OCR computer vision system. There is now, there used to be one in the city center, but now there is also one in Belval that will probably be launched in the next few weeks. There is an autonomous driving bus that rely heavily on cameras, so on computer vision systems to detect any incoming traffic lights, and also detect like the lines on the floor and the stop signs. Also, there is for waste management, so for efficient recycling, there is a startup in France that is doing object detection that have cameras directly mounted on garbage bin collectors. It can speed up the whole process of recycling. Another kind of interesting and unexpected but kind of clever use case is to detect swimming pools using satellite imagery. This can be really useful for local governments that use this for property audits, because some don't really declare their swimming pool, and then also sometimes there are some zoning enforcement. So these are all kind of a task where computer vision can be used, and also a major part is in the health sector. So there's a high chance that the next time you go and do a scan for either if you have a fracture, that it will be that your doctor will be assisted by probably a computer vision system. All right, so now I'll briefly mention the projects that we are working on here at LIST. So we have a 3-year or 4-year project with a company named Wagner Biro that is expert in stage systems. So they install huge decor stage in theaters and opera. And sorry, I'm just going to finish this slide and I'll answer the question. And they are using, so in between scenes, they are using this kind of system to modify the background, but they are using really large cards that are dragged by cables, and they want to have a more optimized kind of a smart cartwheel system that are interconnected and more movable, easily movable. And we also have a project in benchmarking some computer vision systems. So there are a lot of open source libraries that are really efficient that we can actually benchmark depending on the conditions. So, for example, we are trying to see if a computer vision system can be quite efficient in detecting some cars in different type of weather condition, and it's kind of important because we want to be sure that for crucial projects, this system can be robust. And also, I mean, another project that's being done by the environmental department is to detect ship vessels using satellite imagery. So some satellite imagery have some cloud cover, so it's kind of hard to detect them. And so they use kind of a multi-source of satellite imagery to actually combine them and have a better detection. So there is a question from Laurence. Fast control. Okay, I mean, I will probably answer a bit later towards the talk. All right, so yeah, I will mention briefly the case study we had with a Luxembourgish company a few years ago. So it was part of a collaborative research project, and the aim was to perform some object character recognition from their scan. So it was just a piece of paper that was scanned, and on it were quite important, crucial industrial parameters that we needed for another solution. And the idea was to digitalize all of these scans in one go. And doing that, the challenge doing that manually would take quite a lot of time. So the idea was to suggest a type of computer vision algorithm that is quite well known. So the YOLO is for you only look once, and we use that for OCR. The idea was to pre-train that on some open source data. So there is a large collection of open source data with handwritten digits. The fact that the factory workers had different handwriting was a bit of a challenge because we had to kind of merge and make the distinction between European and American handwriting. And at the end, we also provided them with a dashboard that I can actually see and import directly the scan and have it completely digitalized. So the image is blurred because it's for confidentiality reason, but in essence, there are some rows and columns, and from some part of the scan, we wanted to extract some region of interest, and there the parameters were some values with sometimes a comma or not, and we wanted to extract that information. And the challenge for that is sometimes the scan that were the fish that were scanned were not perfectly aligned, so we had to find some way to find some anchor points and make sure that the same area of interest would be more or less at the same in the same area for all of follow the scan. We also had to manually label some images, but given the fact that there were 5,000 to 10,000 of them, we had to come up with an innovative solution to not just manually label some of them and then kind of do some transfer learning, and we will talk about that a bit later. So the whole pipeline was, we have a template that's supposed to be well aligned. We have a candidate scan. We extract the region by doing some pre-processing and key point matching. And once we extract the region, we remove some borders, some noise, resize everything, and then this is where we built our custom-built model, and we had a prediction, and we could store in a database later. Right. So the main architecture behind this model was the you only look once, that actually was developed something around 2016-17, and it works really well for images, and it captures spatial correlation quite well, and it's really fast and quite accurate. And the advantages is it can detect several objects in a single image. Which was for us quite interesting, because we had sometimes a comma, sometimes we had longer digits. It was not a fixed number. So one of the challenges that we encountered was that the handwriting was different for several workers. So we had to kind of implement a custom generation of new digits that would kind of mix a bit everyone's handwriting, and then we trained our model on that, and this is how we managed to increase a bit the accuracy of our model. And we also wanted our model to be robust, so to be confident in its predictions. So for each images that we generated, we kind of tweaked it and added some noise, and to make sure that for each modification, the model would predict the same thing. So then we can assess if the model was actually robust or not, kind of a safeguard. So what was the business impact is, obviously, the processing speed was completely completely better than a human inspector. Also, there is a lower labor cost over the long term compared to, let's say, commercially available systems like Google or Azure or IBM. It was actually performing better because it was trained on particular data. And the detection rate was over 95%. So most of the numbers were detected. But since the handwriting was sometimes really hard to read, even for a human inspector, the accuracy was in the 75% range. So that was one of the case study we did with the company. And as my colleague mentioned earlier, there are also hands-on workshops that we offer that are 3 hours long, where we go in depth into the coding part, where we picked another case study. So in that case, it was visual inspection of bolts and nuts, where the aim was to classify the different categories of bolts and see also if some had defects or not. So the workshop usually covered the whole process, the whole life cycle of the machine learning, the whole machine learning life cycle. So starting from image collection, for example, there is Kaggle, RoboFlow that have a lot of open source data, data preparation and labeling, so using some open source software. Model preparation, so choosing the right model, doing some fine-tuning and transfer learning, and evaluating to see if the model is good enough, and also doing a fast prototype, so then someone can just click and drop some new image, and having a kind of an interface with a running machine learning model behind it. All right. So now I will go a bit through the kind of whole life cycle of a typical machine learning project, starting with the data collection, how and where we get the data, how we will label them, so using open source software, and that would be useful for the exploratory data analysis part, where we kind of investigate if the data we obtain from open source data, often they are not that detailed, or they have some issues. So we need to investigate a bit the distribution of the image. Are they classes imbalance? Are there too many defects, or are they too many pieces from one single category? We have to discard some corrupted and low quality image. And then also like talking about all of the pre-processing steps that needs to be done for the image to be fed to a machine learning model, and also the part where we split the data into some training, validation, and test set. So the main tool that we showcase in this workshop are OpenCV or Pillow. The data set can be from Huggingface or from RoboFlow, or also Kaggle. There is also some Python library that can do some image augmentation quite easily, and most of the models are trained or comes from, implemented in PyTorch. So overall, what is really the life cycle of a machine learning project? Yes, I will be. I'm not sure if we can share the slides. Do we usually share the slides? Yeah, we can share the slides at the end of the webinar. So overall, it starts by choosing an appropriate model that can come from a database of models, such as Huggingface. Huggingface has a repository of models, but also dataset. And it's already pre-trained, so the weights of the models are already there. Once the model is chosen, we can use the images that we labeled and pre-processed to see how it does. If it doesn't do really well, then we can retrain it, and so on. And this can be, there are some, let's say, Python libraries that can be used for running this whole cycle quite smoothly. So Hydra is one of them. It's a simple let's say configuration management library where you can specify some configuration files from the dataset point, from the model point, what metrics you want to calculate. And also using MLflow, you can have let's say a logging and tracking of all of the models you implemented. So you can pick the best one, and if you have to go back in time, you can select the one that you found was working the best. And then at the end, we evaluate our models, so using kind of a classical metrics, so especially for classification. So if we do a detection kind of task, then we have different metrics. We have to make sure the bounding box that we predict are matching the ground truth. And I mean, this will all be also mentioned in details during the workshop. So there's a big difference between what we do in academia and also what a company wants to have to do if they want to have a product that they want to deploy. So in academia, we usually select the problem, we collect the data, we clean, and then we do an iteration of the models. And once it's working well, we evaluate and we write a report. But for a product, there is constantly a drift, let's say, in the incoming data. So sometimes the business needs change, or the quality of the data change. So it needs to be constantly monitored and tracked. And this is where the life cycle is a bit more complicated, and often if it's a bit the equivalent of having in a lab an experiment that's working, but then you need to manufacture it on a large scale. There are some constraints that arises, and it's a bit the same thing. There are a lot of constraints that needs to be taken care of. And so I'm not going to go through all of the different points, but we can see that the whole life cycle can be divided into three main ideas. So the whole business understanding, that is quite important, because a lot of time we want to use an AI powered system, but we don't really need it. So having a really good understanding of the business, choosing a single use case first, and making sure that the data we have are good enough, and making a kind of a feasibility study. And then later on, once this is validated, we go on the whole pipeline of preparing the data, checking the algorithm, like we mentioned before. And then a big part of that after is to deploy the model into production. So the deployment part needs to be as automated as possible, and needs to be also optimized and monitored. So here's a kind of list of all the technologies and tools that are used for the whole life cycle, starting from the data on the left. So as I mentioned, there are data sets that we can collect from open source repository. So there is Huggingface, that's a really large one. There is TensorFlow, Kaggle as well. There are some kind of a pipeline that automates this whole ingestion of data, such as Airflow, and that kind of streamline the whole process to store this into databases. Regarding the data, also having data versioning, so not having a copy of different files that can actually complicate the whole process. And then regarding the development parts, I mean, as I mentioned, PyTorch is the most common library for computer vision so far. We can also track the life cycle of the machine learning via MLflow and TensorBoard, making sure that our code is up to date using Git, and also using, if possible, we can use some online cloud provider that can have a kind of an all-in-one, such as AWS or Google Cloud Platform. And for the deployment, it's making sure we have a continuous integration and testing part. So what are the technical limitations, let's say, when computer vision may not be, let's say, suitable? That would be in the case where we have not a lot of contrast between, if we take, for example, a product that has a defect, if there's not a big contrast between two products, there are not clear visual differences, then it might not be the best way to go, even with a well-trained model. When there are, for example, in an industrial process, there are some highly variable lighting conditions. So if it's an outdoor settings with kind of inconsistent lighting, it can confuse the model. We had kind of this issue with the benchmarking for cars in different weather conditions. So like shadows, glares, and reflection can be a big challenge. Depending also on the size of the defect. When defects are on a microscopic level, that kind of is above the resolution of the camera, that's probably not going to be a good application for computer vision. It can be combined with other techniques, but on its own, it won't work really well. And maybe for transparent reflective material. And then in terms of business consideration, for our case study, the business need was not necessarily, the volume was not necessarily really high. So maybe there wasn't really it was not really important to have a computer vision system for this particular task. If we are only producing a few units per day, the return of investment from investing in a full computer vision pipeline might not justify the cost. Also, when we are frequently changing the product, each new product type needs to have its own model, or at least it has to be fine-tuned. That can introduce so time, cost, and increased complexity. And in also tight space constraints, it can be quite tricky also to have this kind of a system. And when there is really a high mix of products, so a high product-to-product viability, if there is like 50 different shapes or packaging style, then data or like images need to be collected, and then the complexity can get really high. And in these cases, simpler rule-based automation might still be preferable. So there are in these cases there are actually alternative solution. So when it's not the right fit, we can also use some hybrid approach, either some traditional automation, some rule-based system, or mechanical sensors that can do the job more effectively. Some manual inspection with some digital support. You can augment human inspection with digital tools. Kind of thinking about semi-automated labeling or magnification systems, and then kind of a hybrid human AI kind of system where let's say the computer vision system handles the repetitive parts, and the human kind of makes the final call. We have this in medical imaging or mostly in medical imaging, where we need both the input from the doctors and the computer vision system. So the key takeaways, let's say, of this webinar would be that computer vision has been transforming industrial processes the past 5 to 10 years, and keeps growing. The latest deep learning approaches, they can achieve really high human level accuracy. There could be some significant return on investment and some labor savings for some case study, and then the successful implementation requires careful problem analysis and a well thought machine learning pipeline, and that also not all applications are suitable. There's a need to evaluate the technical and the business factors. So that would be for me the end. I've put a bit of a resources regarding the tech stack, so that open source framework. We mainly use OpenCV, YOLO, and PyTorch. And for the open source data, like I mentioned, there is Huggingface dataset. There is also in Luxembourg the data.public.lu, which is a repository of a lot of open source data regarding Luxembourg. And if you're interested in looking at the latest state-of-the-art research, papers with code is a good reference. You can have a ranking of the latest algorithm, and then you have also Hugging Face models, where big companies like Google, Facebook all share freely their models. So for me, that would be it. So I'll start to answer a bit some question. So in manufacturing, so Laurence is asking, in manufacturing process, we are looking for fast control. The implementation of the vision system should run from 30 meter to 300. Is it millisecond or? Okay, is it feasible? So regarding speed, there could be some implementation that are leveraging on GPUs, and often what takes a lot of time is the training part, but the inference or the prediction of the classification of or the detection of the object is usually quite fast. So that needs to be investigated, but I think it should be feasible. That it can detect really quite at high speed cars, and probably also other domains. So I'm pretty sure it can do it. Okay. Yeah, so regarding the outdoor for the vehicle detection, yes, exactly. So for that, we also have data with night vision. So it's usually a combination of different source, a bit like the case study I mentioned with the satellite. Often we cannot rely on a single source of data. We need to merge several sources, and we can pre-train a model on normal data, and then kind of retrain it on let's say infrared images, and usually that performs better. But yeah, it is a main challenge. is there a gold standard for software selection for whole life cycle of ML production development? So this is quite a really good question, and it's really tricky because the tech stack keeps evolving, and there are some preferences depending on the software developer. But I would say the gold standard for implementing a computer vision system would be PyTorch. Regarding the deployments, there are some open source tools that doesn't require a license, like GitHub Action. There is same thing for code versioning. So there are a lot of free open source libraries that everyone can use. And on one of the slides, I mentioned kind of a whole list, and it's also a question of preference. Some people are more used in using a specific library, some others another one. So it's just with experience. I'm working with very small defects, so the answer is clear. Okay. I have one question to the OCR example. Did you use the object detection model only for the region of interest or for a cluster? No, it was only for the region of interest. Yeah. So we used the you only look once framework, but we had to scale it down because our region of interest was quite small, so something like a 20 pixel by 10 pixel. So we just modified it a bit, but the whole, let's say, architecture was more or less similar. And we didn't train different models for different region. We had one model for the same region. Okay, I don't know if if there is any other question. In any case, thanks a lot for joining, and I hope it helped some of you if you had any questions. Yeah.
Yes, can you hear me?
Yes.
Thank you everyone for participating. Don't hesitate. You have our contact details. If you have further questions, don't hesitate to contact us. Don't forget the hands-on workshop where you can experiment some of the tools Eric mentioned on this visual inspection industrial use case for screw quality. Will be on the 5th of February 2026. If you want to have it before, just call on us. We can plan it before. Check out on the DIH website for our next activities. And if not any more questions, then I will wish you a very pleasant rest of Friday. Thank you.
Thank you all.